Okay, in this lesson I want to look at revisiting conditional probability. And we defined the probability of B given A as the probability of A intersection B divided by the probability of A. Here I've got a partly filled in contingency table. These are showing probabilities for various events. So notice the probability of event A occurring is 0.3, the probability of event B occurring is 0.4. We're asked here the probability of A intersection B. Well, that's 0.1, common to both. We're asked to find the probability of A union B. Okay, to find the probability of A union B, what I do is I look at this cell. This is not, of course, A union B, but what it is, it's A complement intersection B complement. In other words, not in A and not in B. So it's in neither column A nor B. The probability of A union B, the complementary rule, is always going to be the probability of A union B complement. And in this case, A union B complement, that means it can't be in either A or B. So we're looking for the things that are in not A and not B. That's 0.4. So it's 0.6. The probability of A given B, the probability of A given B. Well, that's the probability of A intersection B divided by the probability of the given condition B. So what's the probability that something is in row A given that it's in column B? Well, given that it's in column B, the bottom of my fraction has to be 0.4. And the probability of it being in row A means the top of my fraction has to be 0.1. So we're talking about a quarter here, or 0.25. Or, of course, 25%. What's the probability of B given A? Well, that's the probability of B intersection A, or A intersection B, divided by the probability of A. Okay? B intersection A, of course, is the same thing as A intersection B. The intersection operation is commutative. So, given that we're in row A, what's the probability of selecting something from column B? Given we're in row A, the bottom is going to be 0.3. The probability of selecting something from column B, that's 0.1 over 0.3. That's 1/3. Okay? Or, as a decimal, 0.3 recurring. Okay, so we can work out probabilities pretty easy once we have the contingency table. I can fill in all these other things. 0.1 plus 0.2 giving me 0.3. 0.1 plus 0.3 giving me 0.4. 0.2 plus 0.4 giving me 0.6. 0.3 plus 0.4 giving me 0.7. And then finally, my total down here is 1. And in those contingency tables, if they're showing probabilities, well then the total should always be 1. So that's conditional probability. Let's have a look at another example. So a bag contains 6 red balls and 4 blue balls. 2 balls are randomly removed from the bag. Find the probability of no red balls being removed. Okay, so I'm finding the probability, that the first is not red, and then the second is not red either. So it's a non-red, and then another non-red. Okay? That's what we're trying to do. And that's going to be the probability that the first is non-red multiplied by the probability that the second is non-red, given that the first was non-red. So the probability that the first is non-red, well, there are 10 balls altogether. So my total possible outcomes is 10. The probability that the first is non-red, well, that's going to be 4 out of 10. That means we're talking about blue balls here. And then the second is non-red. What's the probability the second is non-red? Well, the probability the second is non-red, given that the first was non-red, so this is important, the condition is important here. The probability the second is non-red, given that the first was non-red. Well, if the first was blue, that means there's only 3 blues left in. And no longer are there 10 in to choose from, but there's only 9 because we've already removed one. Okay, reducing that fraction, it's going to be 2/5 times 3/9. Or 2/5 times 1/3, I suppose. Which will be 2 in 15. There's a 2 in 15 chance that neither of the balls removed from the bag will be red. Okay. And there's a condition there on the second one. We're given that taking the second is red, given that the first was red. Probably the second is red, given that the first was red. So find the probability of at least one red. So same exact experiment. Removing 2 balls from the bag. What's the probability of at least one red? Well, one thing to note, if we think about that word at least one, what is the complement of that? What is the complement of at least one red? Well, the complement of at least one red is no reds at all. Either we'll have no reds at all, or we will have at least one red. There's only 2 things can happen here. So using my complementary rule, remember the probability of any event added to the probability of its complement has to equal to 1. So the probability of any event is going to equal to 1 minus the probability of its complement. And we looked at that rule before. That's the complementary rule for probability. So the probability of at least one red is going to be 1 minus the probability of no reds at all. And we've just seen the probability of no reds at all is 2 in 15. So it's 1 minus 2 in 15, and that'll simplify to 13 over 15. Okay, so there's our first kind of thing on conditional probability. I'll look at some slightly more complicated problems in my next video. Okay, so practice, practice.